So in our previous lecture, we have discussed about the RAD model, and then we have certainly discussed about the ASE11 model also, right? So now we'll be talking about a few models under this ASE11 model. So something called as extreme programming. So we'll talk about that today, and followed by maybe a Scrum process model also will be discussed, right? And there are a few other models like Crystal, Eton, and all. They may be you can go on your own time, and then you can have a reading on these topics, right? So we have talked about the pair programming, right? So that is one of the important aspect of agile model. So and then which takes more of face-to-face communications, right? And we have compared agile model with RAD. Now today we'll talk about extreme programming model. So usually this model recommends whatever the best practices or the practices that have performed well in the past, we should use them again and again. I mean, whatever the practices that have performed well in the past, so we try to use them again and again during our project development. That is what exactly part of this is one of the important recommendation by this extreme programming model. So if something is known to be beneficial, why not put it to constant use? That means if something is beneficial, so then why not we use that particular practice again and again during the development. That is what we say, right? Based upon this principle, it puts forward several key practices that need to be practiced to the extreme. So we'll see. So what are those practices? There are certain number of practices we have. Okay, so usually we try to use them again and again, as per this particular process model. So usually, so here XP is also based upon frequent releases. Here also, we try to develop the software in various through various iterations, right? And each and every iteration actually targets few, one or maybe a few number of features. Usually we can say one or two features, right? So they will be delivered through each and every iteration. Okay, so let's say one example here is, so usually part of every iteration, so the user stories are actually getting implemented by the development team. So what is a user story? So they are the they are the formal statements given by the user. Okay, let's say for example we take an example of a library software system. So user stories can be like this. Okay, so user says a library member can issue a book. Okay, a library member can issue a book, right? If a person is a member of a library, then he can issue a book. Okay, so that can be one user story. Okay, the other user story can be a library member can query about the availability of a book. That means if you are a member of a particular library, so you should be able to search whether a particular book is available in the shelf or not, or whether that particular book is available in the library or not. Right. So these are the actually user stories. Now these user stories will be implemented during each and every iteration. Okay. So after these user stories are presented, now usually the project team, so they comes up with a very common vision of how the system would work. Okay. Usually it is actually the architectural design. So you can essentially think of, right? So contain certain number of modules you can think of again. A small modules you can think of small modules again. So now which module need to be implemented and all, right? That means which user stories need to be implemented first, which user stories should be implemented next. Okay, so those things will be decided, right? A team may decide to construct a spike for some features. Okay, so like usually spike is something. It is also a very simple program constructed to explore the suitability of a solution being proposed, right? So in order to see whether the solution whatever proposed, uh, you know that whether that is suitable or not. Okay, to verify that, so usually we write a simple program. So sometimes it is also called as a prototype. Okay, sometimes it is also very similar to a prototype. So right, a small program, that is what we call as spike. If it is really required for some features, okay, then the team may construct that particular spike. Okay, so spike is nothing but a very simple piece of program, okay, constructed to see whether the solution for that particular problem is suitable or not. Okay, so as I said so there are certainly few good practices available, right? So we'll go through each and we'll go through one by one. Okay, so the first practice here is good practice here is code review, right? So code review is a technique by which we able to detect as well as we correct errors most efficiently. Okay, so usually it applies, let's say one example here is pair programming. So through pair programming, so we are able to review the code. Okay, when one is writing the code, the other one is reviewing. Okay, after after an hour, so their role will be changed. The one who was writing the code now will be reviewing now, and the one who was reviewing, so now will write the code. Okay, this is the way that you review the code as well as. Okay, so pair programming is one way of code review, right? One code review technique, right? So now this is a very good practice because it has given, it has performed, it has given so many benefits. Okay, in the past. That is the reason why we should use this, practice again and again while development, right? And now there is a testing. Okay, so suggest test driven development where test cases are written even before any code is written. Okay, now developing the test cases before you completely develop the source code or the you written the source code. Okay, so this is this practice also have shown benefits in the past. Okay, so we should use this way also, right? So now where we have seen this sort of, in which process model you have seen, right? These test cases are designed well before the coding is written. Can anyone, any student? In which process model we have? Yes.
B model.
Yes, B model. So we have seen, so part of B model. So I mean, before you develop the, before the code is written, so the test cases are developed or designed. Okay, so now, so this sort of, this is also one sort of good practice. Okay, and there is a incremental development. Okay, so so that is also a good practice because in an incremental, in each and every iterations, right, we deliver the software at the client side and then we try to take the feedback from the client or the users, right? And based upon the user, so we try to modify accordingly the software, and it will be released in the next version. Okay, so this is also gave lot of benefits, right? So this is also a good practice. And the other one is a simplicity, right? So I mean, if the simplest code ignores the aspects such as efficiency, reliability, maintainability, right? So now you start writing a very simple code. Okay, I mean, the simplest code always, will not take into account the efficiency, maintainability, as well as reliability. Okay, so they will be actually handled through refactoring. Okay, basically you start with the simplest code. Okay, you achieve the functionality whatever really required, you achieve that functionality. Okay, and then later on what you can do is by through refactoring, I mean, you divide that piece of code into small units, right? So as to improve the operation, right? So as to improve the operation or the maintainability, like if you divide the whole source code into some modules, small parts, uh, through which you will be able to maintain the source code properly, right? So that can be done later on through this refactoring mechanism, through refactoring, right? But initially, always this simplest code whenever you develop, so that will not take into any account the performance, reliability, and all maintainability. These are the issues. Okay, so they are the non-performing attributes. Okay, non-functional attributes. Okay, they are the, so will not take into account. So that is the good practice. First, you develop the simplest code, okay, which meets the functionality, and later on you can think about improving the non-functional attributes like reliability, maintainability, efficiency, and all. Right now, the other practice here is the design. So everybody should design daily. I mean, you should keep on you should keep on involved in the daily designing process every day. Okay, that is what it all says. So you should always involved in the design process, right? So quality design can be achieved through refactoring. Okay, so if you have a better if you have a better design, right? So then you will be able to achieve the non-functional attributes such as readability, maintainability, that can be achieved through the refactoring also later on, right? So I mean, as I said you, so whatever the individual modules that you have, whatever the module you have initially, that you can further again divide it into smaller modules, and so in a way that you will be able to maintain that particular piece of code properly, or to increase the readability of the source code, right? So those things can be done through the refactoring also, right? So initially you come up with the first design version of first design, you first come up with a version of a design, and then you keep on improving that design through refactoring. Okay, so that means you try to, I mean, modify the design in such a way that will not affect the external behavior of the system. Okay, so that means the functionality should not change over time. The functionality should be the same. Only thing that you will be trying to improve the non-functional attributes such as maintainability, readability. So you try to improve the readability, right? That means you will make it easy to understand the piece of code. Okay, so you will write that code in such a way that it will be easier for the others to read it, understand that particular piece of code. Okay, so these things can be improved through refactoring. Okay, now the other good practice here is integration testing. So you should always try to identify the bugs at the interfaces, because when you integrate these modules, then only you will be able to see bugs at the interfaces, right? So you should always keep on integrating these modules. Okay, like if the developers, they should always integrate something so as to find the bugs at the interfaces. Okay, so this process can be carried out many times a day. So then only you will be able to detect errors at the errors or the bugs at the interfaces. Okay. Now, so these are the these are the certain good practices we have seen. So you should always try to use these practices to the extreme. That means you try to use these practices again and again. This is what according to the extreme programming. Okay. Now we'll see certainly several activities. They are part of this extreme programming development model. Okay, so there is the first activity is a coding phase. Okay, so what this coding activity does here? So usually, so you know that utmost care and attention needed for coding activity. Yes, true. You should write the code very carefully. Without coding, it is not possible to have a working system, right? So I mean, so in order to have a working system, you need some executable source code, right? So you need to have the code, right? Coding in extreme programming has slightly different meaning. So here, according to extreme programming, so the coding has little different meaning as compared to the traditional development models. So here, so coding activity will take an example here. So coding activity includes drawing diagrams, modeling. That means uh, you will be going through some modeling, right? That means in terms of some diagrams. Okay, you will have some diagrams, and these diagrams will be automatically transformed into piece of code. Let's say one example is, so you will have let's say there is a unified modeling language, UML. We'll talk about that when we are going to discuss about object oriented design. So we'll talk about that, right? So usually what will happen, let's say there is a diagram called activity diagram, right? Now once you have developed that activity diagram, so from that activity diagram we can generate a piece of code, okay, automatically. Now that is what we say. So here because extreme programming is something where the coding means this sort of activity is involved, okay, or writing scripting a web-based system, right? Or choosing among several alternative solutions. Let's say you have certain alternative solutions, you will be choosing here one of them, right? So that will be also part of coding activity. Okay, so whatever the code related things, right? So all will be uh, taken considered here part of coding. Okay, so in traditional, so piece of writing code, right? Here not only writing code, that means that code can also be generated through modeling. Okay. Now the other activity here is a testing. Okay, so usually we know that so always we need to give highest priority to the testing. So and testing also takes more effort in development phases, as you know. So it's a way by you will be able to identify all the defects or the faults, right? And you try to make the software fault free, right? So this is also an important activity part of extreme programming. And now the next activity here is a listening. So what it all says, so developers need to listen to the customers carefully. So because so in part of extreme programming, so you will have 6 to 9 people working. It's a small team, right? And usually you know so I mean these team members should properly, I mean developers need to listen to the customers carefully to identify what are the different features, right? So if you have not understood what they want. So probably we will end up with software failure, right? So that is because usually the customers are the users, or the where the people who is going to use that particular software. So they might have, usually they have better domain knowledge. Okay, so that is the reason why uh, you should always listen to them. Okay, let's say you going to develop a software for banks. Okay, so first you need to you should listen to the people who have banking domain knowledge. Okay, so because programmers may not have that much of banking knowledge, right? So that is what usually happens. So you should always listen to the customers very carefully, right? So that is the way only we try to identify, or we try to know exact requirements. Now the other activity here is a designing. Okay, so what will happen if you do not have a good design? So usually the implementation will become very complex. And let's say, for example, if the modules within a particular system, they are dependent on each other too much, then what will happen? So it will be very difficult for us to understand the solution. Okay, that means we will talk about the software design, then we will be able to, during that we will talk about the coupling, and we'll talk about cohesion and coupling. These are the two important topics, right? So that means these modules should have high cohesion and low coupling, right? So this sort of thing. So now if these modules, if they are too much dependent on each other, that means it is very difficult for us to understand the solution, right? So, and also it will be very difficult during maintenance also. Let's say if there is a, you can think of like this, if there is a module A, B, C, if they are dependent on each other. Now let's say you experienced a fault at B. Okay, you experienced a fault at B, module B. Now it is very difficult for you to understand whether this fault is actually created in A or C module. Okay, because they're all dependent. So once that module is occurring there, so that means unless or until we correct this module fault at B, now you cannot run module A and C, right? Because they are dependent. So this is what happens, right? So this is the way that it creates lot of difficulty during maintenance, right? Emphasizes use of suitable design technique. So it all says that you should have a appropriate design technique in place so as to come up with a good design. So that is what we say. So this is also a one basic activity under extreme programming, right? Now feedback, the other one is a feedback. So understanding the exact requirement, feedback is critical to learning and making changes, right? So through feedback only you will be able to understand the requirements, exact requirements. So that is what it says. So that is through the iterations we have seen also, right? So it has an incremental delivery. So as a mean, through that mean, so usually you take feedback from the customer, right? And you try to learn, and certainly you try to make some changes in the software, right? Frequent contact with the customer makes the development effective. So I mean, you have a better interaction with the customer. So that is what one of the good activity that is part of extreme programming model. Now simplicity, the other one is a simplicity. So build something simple that will work today, rather something taking a lot of time, never getting used. Okay, so what it says is, so you build always little thing. Okay, so I mean you build those functions which are really immediately they are required or they are needed. Okay. And what you do is you implement all of the features by taking lot of time, and by the time you deliver that particular software, maybe that is no way useful to the customer. As a result, what will happen? So that will be useless again. Okay, so whatever really required, immediately needed, so you implement them first. Okay, rather you spending enough time in gathering all sort of requirements at once, right? So and then you implementing that particular software and delivering to the customer. Okay, so it's better that you start with something, some few user stories. Okay, so then where you can apply, I mean, so what are the applications of this extreme programming model, or where you can apply this extreme programming model? Okay, so wherever the projects involving new technology or research projects, if it is a very research project, in part of research project, so usually the requirements change very rapidly. We may not have seen some technical problems which might uh, usually appear, right, more often. So now somehow, so whenever there is a project, and if that project has it's of something research kind, so usually uh, we can use this. Okay, now the other one here is small projects, because as I told you, so here mostly we execute this project um, through the development team, where these members have face-to-face meetings or communications, right? So if it is a very small project, then it is very easier for us because these meetings can be conducted. If it is a large project, then I told you you should arrange some sort of video conferencing mode. Through video conferencing mode you can achieve, but that little difficult as compared to uh, if it is a very small project, right? So you can apply to small projects because the face-to-face meeting is easier, right? And wherever you require much of requirement changes, so that sort of project can be applied, because it exactly takes the customer feedback and then try to resolve it in resolve through different iterations. Okay, now some characteristics that are there with the applications which will make this extreme programming model not suitable. Okay, yes, Rajat.
So, actually, they were analysts, like in order we had an analyst who was collecting the requirements. So compared to that, like here the only developers will be in direct contact with the customers, or like how is that?
Yes. So whatever the development team will take all the user stories. Okay. So user might have given all these things, right? So user might have told ki, these are the things, like as I given an example of a library. So user might have given all these stories. Okay. And after we collecting all of these stories, and then we take up these stories one by one, few stories will be taken up by the development team and they will implement that story, and then that will be delivered to the client. Now after taking feedback, they try to modify again and again. Okay, so here I mean there wouldn't be having a strong systematic development approach. Okay, usually where we try to do, you gather all the requirements and then you analyze those requirements, and you so as to find all the contradictions, incompleteness, as well as inconsistency. We remove all of them. Thereafter we're going to the design phase, right? So these sort of things will not be done here. These issues will be handled through the development team itself. Okay, is it clear?
Yes, sir. Like clarification, like there's no like documentation like SRS document, like where
Yes, that is what as I told you before while having discussions on agile model. So it is also a part of it's one of the agile model, right? So when I was having discussions on that agile model, I told you, right? So usually they have little less documentation. As a result, it creates a lot of problem when during maintenance and all, right? So now, so there are certain characteristics which will make the application not to use this extreme programming model where, so if the requirements are very stable, okay, that means the requirements usually whatever the requirements you gathered, so usually they do not change over time, okay. So then what we need to do, you should go with the iterative waterfall model or the waterfall models, okay, or variants of waterfall model, okay. So there you cannot use extreme programming. So extreme programming where the requirements will keep changing, okay, over time, okay. So now it cannot be used for mission critical or safety critical system, as I told you. So here because in mission critical and all, so you will have very adverse effect when some of these faults are if there are any faults present, or some of these requirement are missing, right? Or so here mostly the reliability is very important. So we cannot afford the failure of the system, right? If there is a failure, so then it will lead to several consequences. Now you can think of maybe radar communication systems, okay, which are usually used in military applications, right? So for combating fight and all, right? So let's say if your missile is not working, if that missile failed by the time you fired, so what will happen? Usually the missile from Pakistan will come and hit us, right? As a result, we'll lose lot many lives, right? So you can think of this sort of example, right? So wherever the strongest reliability are required, so you should not go with this particular type of model, okay? Now we stop here for this particular process model, right? So I will upload another model. Just give me a minute. So far, any doubt in this process model? Student, any doubt so far?
No, sir.
Okay.
No, sir.
So I will start. I'll upload the other slide, which contains the slides of Scrum process model. Just give me a minute. Can you see here the slides?
Yes, sir.
Yes, sir.
Okay. So here is also something like this. So whatever the entire projects that you have, that will be divided into small parts. Okay. I mean working parts, and these parts will be incrementally developed and delivered over time boxes. So as similar to RAD model we have seen, and so similar to extreme programming, right? So here also we call time boxes, right? Small amount of time during which we try to develop a part, right? And these time boxes are called here sprints, okay? They are called here sprints, okay? So I mean whole development will be carried out through several number of sprints now, okay? So here it is a self-organizing teams. So the team, when I say self-organizing teams, that means the responsibilities, whatever the responsibility will be there. So those responsibility will be distributed among the team members by themselves. Okay. So that is what the self-organizing teams. Okay, so let's say for example there are 5 members, so one will be taking up the testing related, the other one will be taking about related to quality assurance, the other one may be going and designing user interfaces, right? So likewise, so now as I told you, there is a 6 to 9 people, so now these people will distribute themselves the responsibilities, right? So that is what exactly self-organizing teams. Okay, so that is part of Scrum also. So product progresses in a series of month-long sprints. Now, so each and every sprint takes 2 to 4 weeks. Okay, so usually it is a month long. Okay, 1 month long. So duration of each and every sprint or the time box here is 1 month. Okay, or 2 to 4 weeks. Okay, 2 to 4 weeks. Requirements are captured as items in a list of product backlog. So there is a product backlog. Okay, so whatever the items are captured, they are they are provided as a individual item in a list of product backlog. Okay, there is a product backlog, right? So we'll talk about that. So one of the agile processes. So this is also one of the agile process. Okay. Now usually you have a product backlog. That means they are the requirements you have. Ultimately, there are certain items that will be there in the product backlog. Okay, and there is a sprint planning. That means before the sprint starts. Okay, so usually during this sprint planning, exactly what are the different items that will be developed through a particular sprint. Okay, that will be decided, and those items will be there in the sprint backlog. Okay, product backlog means it is the whole set of requirements. Okay, now sprint backlog is the subset of product backlog. Okay, so that means these are the items that will be developed during a particular sprint or a iteration or time box. Okay, now there will be a daily scrum. That means that will be performed, those features or the items will be developed or the requirements will be developed through Scrum. Okay, so you will have, as I told you, this sprint lasts for at least 2 to 4 weeks, right? So there will be a daily Scrum. Okay, every day you will try to work on those features. Okay, certain number of features, right? And ultimately, once during the end of that sprint, so there will be a review, and then so that particular increment is released. Okay, that is what we say product increment. Okay, we'll talk about each of them. Okay, so what is a sprint? So usually that is very analogous to time boxes. You understand, right? So during a particular iteration, you try to you try to design, develop, and test the particular features. Okay, or user stories. Okay, and so it is a 1 month or 2 to 4 weeks. Okay, so software increment is designed, coded, and tested during the sprint. No changes entertained during a sprint. That means whatever finalized, I mean, these are the item needs to be developed during that particular sprint. That means that will be developed by the sprint. Okay, during that sprint development, I mean during that particular sprint, so no changes are entertained. That is what you need to understand. Okay. If at all any changes required, so those things will be maybe that will be during sprint review. Okay, those things will be recommended, and those will be created as a extra feature, and those features will be added into the product backlog. Okay, that will be added into the product backlog, and that item may be in the next sprint or maybe in subsequent sprints that will be addressed. Okay, so you can think of something like that, but during a particular sprint, so it will not entertain any changes here. Okay, it will not take and make changes according to the change requirements. Okay, it will not do. So now your Scrum framework, so it has certainly a few roles, ceremonies, and artifacts. We'll talk about them each one. Okay, so like here, team members, so they can have, so team members can have any one of the roles. Okay, maybe as a product owner, or maybe as a scrum master, or a team. Right. So right, part of ceremonies, there will be a sprint planning. So ceremonies are the ones which are going to represent, certain meetings that are, carried out throughout the sprint development. Okay. So that is one sprint planning meeting, sprint review meeting, sprint retrospective, and daily scrum meeting. Okay. So these are the various meetings that are held during the product development. Okay, and you have a various artifacts. So these are the deliverables. So maybe one is product backlog, the other one is a sprint backlog, and there is a burn down chart. We'll talk about that. So here we see some key roles and responsibilities associated with each and every Scrum team. That means the roles and responsibilities of team members. So there is a product owner. Okay, he actually represents the customer view and interest, right? So you can think of, whatever the user stories need to be developed. Okay, so he is the one who is going to represent those user stories. Presenting those user stories, right? So guide the team toward building the right software, right? So he is the one who is representing the customer. That is the reason why. So ultimately, he will help you in help the team to building the right software, because if the requirements are not known, okay, and then everything, I mean, if the items, whatever the features need to be developed through a particular sprint, if that is not known, so then what will happen? Ultimately, we are ending up with a wrong software, right? Developing a wrong software, right? So now there is a development team. So team of 5 to 9 people, as I told you, with cross-functional skill sets. That means the people are from people with different skill sets, as I told you. Now one may be good at user interface design part, and one is taking the responsibility of testing. The other one might be taking the responsibility of designing. So this way you can think of. So it is a cross functional, and the other one may be quality assurance related thing, right? So there is a team of 5 to 9 people, right? So, and there is a project manager, or you can say scrum master, okay, also known as project manager. Okay, so he is the one who facilitates the scrum process, and also he try to resolve any impediments that the development project is going to face. Okay, if at all any impediments or any problems that it is going to face, so those things will be resolved by the project manager, right? And also sometimes he acts as a buffer, between the development team and the outside world, right? So I mean, so the outside world cannot interfere with the development team, as I told you. So no changes are entertained during the sprint. That means they are not going to take any suggestions outside the development team, right? So now this sort of, if at all any problems arises, or understanding between the team and organization, so that should be resolved by the scrum master. So these are the various roles. So these are the 3 roles involved in a scrum process development model. Okay, now we'll see the responsibility of each and every role. Okay, what they are all doing. Okay, so usually the product owner defines the features of the product, as I told you. So he is the one who represents the customer view. Okay, so ultimately he guides the development team in developing the right product. That means he's defining the right features. Okay, what is really required to be developed. So that is what defined by a product owner decides on release date and content. What is that what is that particular increment that should be released on what date, in which sprint. So these are will be decided by the product owner. Okay, as well as he sometimes he also prioritizes the features, like some of these features are very immediately required. Okay, so now according to these requirements, he can adjust certain features, right? Maybe the prioritized features will be included in the current sprint, and maybe the features which now planned, so maybe they are not that much prioritized ones, so then they can be moved on to the next sprints. Okay, because we develop the whole software through different setup or the series of sprints, right? And sometimes he because he is the customer view, so he is going to whether sometimes he'll accept or he can reject whatever the result comes from each and every sprint. Okay, if the sprint is not meeting the requirement of the user, usually the product owner can reject. Okay, because he's representing the customer view. Okay, now what are the responsibility of a scrum master? So he represents a management in the management. Okay, so product owner represents the customer, so here the scrum master represents the management in the project. Okay, so usually so he's going to handle he's going to take all the responsibilities. Okay, whatever the problems that occur or impediments that they while developing the project. So the scrum master usually he tries to resolve all these impediments, ensures that the team is fully functional and productive. So that means he is the one who is monitoring, so monitoring to ensure that the people are working well towards their goals, right? And there are also so they do maintain a well cooperation, a very close cooperation among different roles also, as well as their functionalities also. And as I told you, this team manager or the scrum master, he also shields the team from external interferences, right? So that means, so no one is going to interfere with the development of a particular sprint. Okay, he is the one who is going to shield from any external interferences. Okay. The other one is the Scrum team members. So typically 5 to 10 people or 5 to 9 people. So they are all of cross-functional skill set. They have very cross-functional skill set. That means quality assurance. Some are programmers, some are user interface designers, some are testers. Okay. So like this. So the teams are self-organizing. As I told you before also, as I explained you before also. So the whole responsibilities are being distributed among all the team members by themselves, right? So the membership can change only after between sprints. Okay, so during the sprints, so no member can change. Only the membership, if you want to change from the membership can be changed only after the sprint or before the start of another sprint. Okay, so that is what exactly the Scrum team is all about, right? So now, as I already explained you, so it is a very fundamental process flow of Scrum. It is usually a month-long iteration, as I discussed, right? So during this time, so you incrementally develop something. Some functionalities are developed. No outside influence allowed to interfere with the Scrum team during sprint. That means there, your Scrum master actually acts as a buffer, right? So you will not allow the others to interfere with the Scrum team. Each day begins with a daily Scrum meeting. So as I told you, so this is one ceremonies part of Scrum, that is the daily Scrum meeting. This is the meeting actually created, every day. Mm. So I know each day the Scrum starts with this daily Scrum meeting. We'll talk about that also. So there are these ceremonies. So as I told you, sprint planning meeting, so daily Scrum and the sprint review meeting. Okay, so we'll talk about these all meetings. So right, so part of sprint planning. So goal is to produce the sprint backlog. Okay, goal is to produce the sprint backlog. That means what are the different features that need to be developed during a particular sprint. Okay, so that is to be planned. That means the setup, features, the items that are mentioned in a product backlog. So it will be taken from that, and it is to produce this, it is to produce this backlog. Okay, so team members commit to develop, deliver certain features in the ensuing sprint. Okay, so whatever the features will be chosen, okay, during this sprint planning, so they will be handled through the following sprint. Okay, so the product owner works with the team to negotiate what backlog items. So as I told you, so product owner, he's the one exactly represents the customer view. He is the one actually wants what features to be developed when. So now these are actually, in consultation with the product owner, we finalize what item needs to be included in this particular sprint. And Scrum Master ensures team agrees to realistic goals. So here the Scrum Master always ensure that whether the team is agree to the features, or whether they are feasible to develop, or they are realistic or not, right? Something unrealistic ones should not be taken up, otherwise we will not be able to deliver that, during a particular sprint, because it is a very short duration, right? So there is a daily Scrum, as I told you. So no, this daily Scrum meeting always starts with a particular day, okay, of Scrum. Let's say as I told you, so Scrum lasts for 2 to 4 weeks. Um, it takes 2 to 4 weeks, right? So now every day, so in the morning, so there is a stand-up meeting among the team members, right? So it carries for 15 minutes just to review the status of progress achieved so far. I mean, it is to review what has achieved so far. Okay, so it is not a problem solving meeting. So we are not trying to solve the problem through this sort of meeting. Rather, it's a problem. It's a meeting to find the progress. Okay, so usually these are the three different questions are being asked. Okay, I mean, what did you do yesterday? What will you do today? And what obstacles are in your way? I mean, what is that you did yesterday? I mean, what is going to do today? Okay, as well as if at all any obstacles that are, or if at all any problems that are in between, so as to disturb or not making you to come up with whatever you planned. Okay, so this sort of things will be answered by each and every member quickly. Okay, so that is what that only lasts for 15 minutes. Okay, so daily Scrum is not a problem solving session, it's true. So not a way to collect information about who is behind the schedule. So here we are not, I mean, the objective is not to, who is behind the schedule, who is doing well, this sort of, otherwise what will happen? So there will be some sort of, uh, again, people may not be work properly, right? So that should not happen always. Okay, is a meeting in which the team members review what is done and what informal commitments to each other and to the scrum master. So this meeting during which usually we try to review, I mean, which person or which person is actually committed to carry out a particular task. So you have committed that in front of all other members, including the Scrum Master, right? Is a good way for Scrum Master to track the progress of the team, right? So this is the way that only the Scrum Master able to see the progress. I mean, whether they are not doing well or not. So you have a sprint review meeting. So as I told you, this team presents what it accomplished during the sprint. That means during this sprint review meeting. So what are the different features that we actually developed? I mean, what the tasks that we have achieved so far in the sprint. So maybe it comes in the form of some demos, right? I mean, you demonstrate the features to the product owner, right? Because product owner is the one who is representing the customer view, right? You whatever the developed these features, so that will be demonstrated to the product owner, right? So usually it takes 2 hour prep time. Okay, so in order to have this review meeting now carried, so at least we need some 2 hour of prep time, right? So and who are the participants in this particular meeting? Usually customers, product owner, management, as well as other team members. That is what customer here usually. So a customer will have, or as well as a product owner also. Okay, who actually gives all the customer views. Okay, product backlog. Now we will see what is part of a product backlog. So a list of desired work on the project. Okay, usually so it's a combination of story based, as I told you also, right? There will be some story based and some are task based. Okay, story based means something they are the functionalities. Okay, let user search and replace, okay, a name or a book. Okay, now task based is something we try to improve the non-functional attributes. Okay, like exception handling, it should handle the exceptions very well. Okay, I mean the more number of transactions should be executed within a time. So this sort of task also. Okay, so usually those things will be listed listed in a product backlog. Okay, so list is prioritized by the product owner, as I told you also. So whatever the features quickly, I mean immediately needed, so they will be given high priority, and the ones which will be maybe not required as of now, so they can be given low priority, right? So this prioritization is also done by the product owner, typically a product manager, marketing, informal customer. Okay, so he is the one who represents. Okay, now part of product backlog, what you have: requirements for a system expressed as a prioritized list of backlog items. Okay, so these are the various items that needs to be developed, and these items are actually managed and owned by the product owner. So usually using a spreadsheet, okay, or it's a Excel sheet. So typically one example you can see how it all looks, right? So like these are the items, item number 1, 2, 3, 4. So these are the features and the descriptions and estimated hours it takes, and by whom it is to be developed, and what is the high priority. Okay, whether it is a very high priority or medium priority. So priority can be given. So this way these product backlogs are created. Okay, now there is a sprint backlog. As I told you, it's a subset of product backlog items, right? So which will be defined and delivered and developed during a particular sprint, right? So these will be created by the team members in consultation with the product owner. Okay, so having communications with after having communication with the product owner, the team members will decide. So these are the actually activities or the items should be included, and that should be part of that particular sprint. Okay, and this is what we call as sprint backlog. Okay, each item has its own status and updated daily. Okay, I mean whether that particular feature is completed or that item has been developed, right? So every details will be updated every day. Okay. Now, when some item is not, let's say for example, some item is developed, but it is not meeting the user's requirement. So in that case, what will happen? That item can be, again placed in the product backlog, as I told you before. And now that product, that item can be again developed through subsequent sprints. Okay. So sprint backlog during the sprint. Okay, so this is what sprint backlog. Okay, so changes occur. Team adds new tasks whenever they need to in order to meet the sprint backlog. So some tasks need to be added, so they can add. So in order to meet the goal of the particular sprint, right? So if team wants some of the tasks need to be removed, unnecessary tasks, are there, so they can remove, right? And sprint backlog can also be updated by the team. Okay, now this sprint backlog can be updated by the team members also, right? As I told you before. But so items cannot be updated according to the external members. So that means no change request will be taken. Okay. Estimates are updated whenever there is a new information, right? So accordingly, you see, sometimes, based upon new features arriving, so, maybe that is added into, some of these, maybe items cannot be implemented during that particular sprint. Okay, so maybe this sort of estimations can also be carried out, and that can be also updated, right? Now there is a burn down chart, as I told you. So this is also one artifact that is coming. So they are used to represent work done, right? So how much work we have done so far in a particular sprint, right? And that is what represented through a burn down chart. Okay. So are remarkably simple but effective information decimator. So this is the way, and this is the way which the project manager can also monitor the progress of others, monitor the progress of the development, right? So there are again three types of burn down charts. One is for the sprint burn down chart, so where we try to see the progress of the sprint only. How many hours left to develop certain number of features in a particular sprint. That is what can be monitored through sprint burn down chart. So there is similarly a release burn down chart. That means it is for the sprints, right? So how many number of sprints so far we have executed, right? And how many sprints that are left, so, right? In order to deliver the complete product. So that is what we call as the release burn down chart. And there is a product burn down chart. Progress of the product can be monitored, right? So we'll see about that. When talking about this sprint burn down chart, so it depicts the total sprint backlog hours remaining per day. So as I told you, so it's a 2 to 4 weeks, right? So so every day there is so every day, so certain number of hours might be remaining, right? And some of the hours, because you have spent, let's say you have decided 24 hours to complete a item, right? So now, so every day you come to the office, right? So you executed certain, you carried out that particular activity, carried out activities for that particular feature, right? So maybe after end of a day, what will happen? Maybe after, so every day you work for 8 hours, right? So that means after end of the day, maybe how many hours left? So there are 16 more hours left, okay, out of 24 hours, right? So this way, so that burn down chart will show you, shows the estimated amount of time to complete. That means through which you will be able to understand how many hours you will take to finish that particular activity or the task or the feature, right? So ideally should burn down chart to 0 to the end of the sprint. So usually that value will come to the 0 at the end of the sprint. So we started with, let's say 300 hours, okay, Now slowly when you spend, and after 10 days or something like that, certain number of hours will be removed, right? Because we have executed, right? So now certain hours are left to finish, right? So slowly we go on to the end of the sprint. When we go on to the end of the sprint, so usually all of the hours are being consumed, right? Usually is not a straight line, so that is not a straight line, you can see. So now what is happening? So the left y-axis represents hours remaining, and the x-axis represents days of a sprint. Okay, the first day maybe these many hours are left, okay, and the second day these many hours are left, third day these many hours are left. Okay, so this is the way that, and sometimes these hours may also increase because maybe you find certain number of items further added into the product backlog, right? As a result, you have to give more time, because you do keep on doing the estimates also, right? If new features comes, so according to that also you need to have modifications, right? So some items will be added, some items will be removed, right? So as a result, sometimes these remaining hours may also increase. So that is the reason, but it is not a straight line. So like this. So ultimately, by the end of a particular sprint, so you will see that this remaining hours will be 0. Okay, that is what it all says. Okay. So similarly, there is a release burn down chart also. So here you have a number of sprints, okay, and the y-axis you have a story points or the stories, right? So how many such stories or the story points are being executed, that is shown. So maybe at the first sprint we have started with these many story points, okay, and slowly we executed, I mean we delivered, developed, and finally by the end of the all the sprints executed, so you have no story point to develop. There is something like a product burn down chart, so it is also showing that usually, I mean, all the releases, after all the releases, how many sorts of product story points that are there, so to a particular sprint. So again it can be represented like this. You can see the red one is showing the expected one, but actual is always like this. Okay, now scalability of a scrum. Typically scrum team is 6 to 10 people, right? But it can also increase up to over 800 people. So in that case you will have the video in a conferencing mode, through which you will be able to conduct various meetings. Scrum of scrums, so that means you can have various scrums, right? You have one scrum, you have multiple scrums, right? So that is the way that you can increase the scrum also, right? As I told you, so the basic the team of a particular scrum is 6 to 10. If you wanted to have a bigger scrum, so you can have scrum of scrums. So any doubts so far, students, related to scrum process model?
Sir, those burn down charts are similar to like countdown kind of thing, right? Like I understood that way.
Which one?
I mean,
this one.
Yes, sir. Like, yeah, I mean, they initially project how many hours will it take to complete the work, and how do they do that?
No, that's part of sprint planning we have seen. Okay, part of sprint planning. So exactly you plan for, right? So what are the features that you need to execute in the following sprint, right? So and how many hours they will take. Okay, I told you. So sprint lasts for 2 to 4 weeks, right? So you should always be stick to realistic goals, right? If some features you have chosen and they can't be developed within that sprint, so that should not be taken care of during that sprint. Okay, maybe that will be taken during other sprint, right? So that is, those things will also be during sprint planning. Okay. And you go on estimating also, right? You need to update the you need to update the estimates also, right, whenever required during the development of the sprint. Okay, clear is it?
sir. Hello? Yes, sir.
Okay. Any more question?
Yes, sir, I have a question.
Yes, ask me.
So in slide number 29, the expected burn down line, how is that? Is it some past
No,
experiences
it
or
is
how is it
expected.
plotted?
We know you. We try to we expect that. You see, there are let's say there are 1,000 story points need to be developed. Okay, these are the stories. Okay, 1,000 stories are required to be developed. Right now, so we expect that these many stories will be solved. Through all these sprints. Okay, now by end of 6 sprints or 7 sprints or something like that, you need to have all these story points implemented, right? This is expected, we expect. Okay, but actually that will not happen, right? So because there are during execution of those sprints, several few more new features will be added, few will be removed, few will be updated. So as or few will be enhanced. As a result, sometimes we so the story points will be increasing, decreasing like this, but ultimately it will have a decreasing. Okay, so ultimately by the end of the year, so you will have all of these sprints are executed, all of these story points are actually developed. Do you understand?
Yes, sir.
Yes. So any more question? I think I stop the recording now. Okay, I will take the attendance also in meantime.